In this video, we will study the composition and properties of matter. As we look at our surroundings, what do you see? Yes, we see a large variety of things around us which have different shapes, sizes and textures. Any object that has a mass and occupies some space, volume, is called a matter. Early Indian philosophers classified matter in the form of 5 basic elements which we know as Panchtattva. These are the 5 elements: air, earth, fire, water and sky. According to them, everything, living or non-living, was made up of these 5 basic elements. Philosophers of the time have classified matter in a similar way. Modern scientists have evolved 2 types of classification of matter based on their physical properties and chemical nature. Let us earn knowledge about matter based on physical properties in this video. Friends, are substances continuous or are they made of particles? Let's find this out by an activity. Take a beaker of 100 ml. Fill this beaker in half with water and mark it at the water level. Now, dissolve a teaspoon sugar with the help of a glass rod. What do you see? Does the water level change? No. How did this happen? What happened to the sugar dissolved in the water? When we dissolve sugar in water, the particles of sugar get into the spaces between the particles of water. From this activity, we can conclude that matter is made of particles. We have come to know that matter is made of particles. But how small are these particles? Let us try to find this out by an activity. Dissolve 5 drops of ink in 100 ml of water. Take out about 10 ml of this solution and mix it in 90 ml of water. Similarly, keep this solution diluted for 5 to 8 times. What do you see? Is the water still colored? The color of the solution becomes lighter each time it is diluted. Still, the water seems colored. This experiment shows that just a few drops of ink can color a large volume of water, about 1000 ml. From this, we can conclude that there will be many microscopic particles in each drop. These particles divide into smaller and smaller particles. Ultimately, in a situation, it cannot be divided into particles and small parts. By this activity, we can say that the particles of matter are very small. Let us now learn about the characteristic properties of these particles of matter. In activities 1 and 2, we saw how the sugar and ink particles were evenly distributed in water. This is possible because particles of one matter are incorporated into the spaces of particles of another matter. It shows that there is enough space between particles of matter. Friends, are particles of any substance immobile or continuously moving? Let us know the answer through an activity. Take a beaker filled with water. Put 2 spoons of tea leaves in this beaker and keep it aside. what do you see after a few hours? We can see that the color of water is changing after some time. Now, if you heat this beaker, what do you see? You can see that on heating the beaker, the color of the tea dissolves more rapidly in water. From this activity, we can conclude that the particles of matter get intermixed with each other on their own. This is due to the inclusion of particles in the space. In other words, we can say that particles of matter are continuously moving. That is, they have kinetic energy. And this energy increases as the temperature increases. This intermixing of particles of two different types of matter on their own is called diffusion. Let us now discuss the last characteristic feature of particles. We will also try to understand it through an activity. Take a copper wire, a piece of brick, and a rope. Try to make them brittle by hammering, cutting, or pulling them. Was it easy? No. But why? Because a force acts between the particles of matter. This force holds the particles together. In other words, particles of matter attract each other. Do all three objects require the same force to break them? No, not at all. This is because the strength of the attraction force between the particles of matter varies in each matter. So friends, hope that now you have got a good understanding of the composition and properties of matter. In the next video, we will study the states of matter. This video. Friends, you must have seen ice melting in water and would have seen water changing into water vapor on heating. From these observations, we can say that water can exist in three states of matter: in solid, liquid, and gas. But have you ever thought about what happens inside matter when the state changes? What effect does the change of state have on the particles of matter? Let us try to find the answers to these questions in this video. Take 150 grams of ice cubes in a beaker and hang the thermometer in such a way that the bulb of the thermometer is touching the ice. Start heating the beaker on low heat flame and note down the temperature when the ice starts melting. When the entire ice turns into water, note down the temperature again. Note down the observation in the change from solid to liquid. Now, put the glass rod in the beaker and heat it by stirring till the water starts boiling. Keep an eye on the measurement of the thermometer until most of the water vapor is formed. Note down the observation in the change from the liquid state to gaseous state of water. Let us first discuss observations in the conversion from ice to water. First of all, we will see when and why ice changes to water. When we start heating ice, the kinetic energy of particles present in ice or solid increases as the temperature increases. As the kinetic energy increases, the particles vibrate more quickly. The energy supplied by heat overcomes the forces of attraction between the particles. The particles leave their fixed positions and start moving more freely. a situation comes when ice, solid, melts and becomes water, liquid. And do you know another interesting thing? The temperature at which a solid melts and becomes liquid is called its melting point. The melting point of a solid indicates the strength of the attraction force between its particles. The higher the melting point of the solid, the higher will be the attraction force between its particles. In this activity, you must have observed that the melting point of ice is 273.15 Kelvin. The process of conversion from solid state to liquid state is also called fusion. In the melting process, you must have noticed that after reaching the melting point, there is no change in temperature until all the ice has melted. The same happens despite providing heat to the beaker. So, where does thermal energy go in such a situation? Actually, this heat gets used up in changing the state by overcoming the forces of attraction between the particles. As this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the beaker and is known as the latent heat. The word latent means hidden. The amount of heat energy that is required to change 1 kg of a solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. So, particles in water at 0 degrees Celsius or 273 Kelvin have more energy as compared to particles in ice at the same temperature. Now, let us see what happens during the change from water to water vapor. When we supply heat energy to water, particles start moving even faster. At a certain temperature, a point is reached when the particles have enough energy to break free from the forces of attraction of each other. At this temperature, the liquid starts turning into gas. The temperature at which the liquid starts boiling at atmospheric pressure is called its boiling point. Boiling is a bulk phenomenon. Particles from the bulk of the liquid gain enough energy to change into the vapor state. For water, this temperature is 100 degrees Celsius or 373 Kelvin. And friends, do you know the amount of heat energy required to convert 1 kilogram of liquid into a gas at its boiling point at atmospheric pressure is called latent heat of vaporization. At 100 degrees Celsius, vapor particles have more energy than water particles at the same temperature. Can you explain why this happens? This is because vapor particles have absorbed excess heat in the form of latent heat of vaporization. By this activity, we can conclude that by changing the temperature, we can change matter from one state to another. Through this activity, we learned that when it is heated, they become solid to liquid and liquid to gas. But do all matters follow this rule? No. There are some substances such as camphor, ammonium chloride, naphthalene that convert directly from the solid state to gas and back to solid without being converted into a liquid state. Sublimation is the process of changing from solid state to gas, and direct change from gas to solid without changing into liquid is called deposition. Let us now see the effect of pressure change on the state of matter. Let us understand this by an activity. You can see that the gas has been filled in a cylinder, and this is how the piston is mounted on it. Now, what will happen if we increase the pressure on this piston? We have already learned that the difference in various states of matter is due to the difference in the distances between the constituent particles. Therefore, you will see that on increasing pressure and compression, the gas particles come closer. If we keep increasing the pressure, this gas will be converted into liquid. Have you heard of solid carbon dioxide, CO2? It is stored under high pressure. Solid CO2 gets converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. Thus, we can say that pressure and temperature determine the state of a substance, whether it will be solid, liquid, or gas. Is it necessary to always heat or change pressure to change the state of matter? Can a liquid change to vapor state without reaching the boiling point? Let us understand this with an example. When we dry clothes, the water in them slowly converts into vapor. How does this happen? What happens to water in such a situation? We know that particles of matter are always moving and are never at rest. At a given temperature, in any gas, liquid or solid, there are particles with different amounts of kinetic energy. In the case of liquids, a small fraction of particles at the surface having higher kinetic energy are able to break away from the forces of attraction of other particles and get converted into vapor. This phenomenon of change of a liquid into vapors at any temperature below its boiling point is called evaporation. Let us see what are the factors affecting evaporation. The rate of evaporation increases with the following: an increase of surface area. We know that evaporation is a surface phenomenon. If the surface area is increased, the rate of evaporation increases. For example, while putting clothes for drying up, we spread them out. An increase of temperature. With the increase of temperature, more number of particles get enough kinetic energy to go into the vapor state. A decrease in humidity. Humidity is the amount of water vapor present in air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. An increase in wind speed. With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. Do you know another interesting thing about evaporation? Have you ever poured a few drops of acetone on your palm? You must have felt cold on the palm. It is also caused by evaporation. Acetone particles receive energy from your palm and its surroundings and evaporate. because of which you feel coldness on the palm. In this way, we can see that evaporation leads to coldness. Isn't it fun? Friends, in this video, we studied the effect of temperature and pressure changes on the state of matter. In the previous video, we studied about composition and properties of matter. Let us now study the states of matter in this video. Oh wow! Preparations for someone's birthday are going on here. Let's see what items are kept here. Here, some sweets and juice is kept for the guests, and the room is decorated with balloons. Do you know what is special about all these things? All these matters are in different states. The piece of sweet is solid matter. The juice filled in the jug is a liquid substance, and the air filled in the balloons is a gaseous substance. Now you may be thinking that how can we find the states of matter? The states of matter are due to the different characteristics of its particles. Let us now study in detail the properties of the three states of matter. First of all, we will study solid state. Collect these items: square copper plate, brick ball and stone. Now, draw the shape of all these objects with a pencil on a paper. Do all these items have definite shape and clear boundaries? All these things are in solid state of matter. Therefore, we can say that solids have definite shapes and distinct boundaries. Now, if we look at their volume, we will find that the volumes of all these matter are constant. That is, there is negligible compressibility. Now, let's do a fun activity. Try hitting these objects with a hammer, dragging or dropping them. What do you see? Have their shape changed? No. Solids retain their shape even when exerted externally. Concrete can break when applied with pressure, but it is difficult to change their shape. Therefore, they are rigid. Why so? This is because there is very little free space between particles in solid matter, and the attraction between those particles is the highest. Can you tell whether solids diffuse among themselves? Let's find this out through a fun experiment. For this experiment, we will need a paper and a ball. Now, try to mix this ball with the paper. What do you see? These two solids cannot diffuse into each other. We have seen that the shape of solids are constant and the volumes are fixed. The attraction between their particles is highest. That is why the compressibility of a solid is negligible, and two solids do not diffuse into each other. Now, let us see the liquid state of matter. Like solid matter, is the shape of matter stable and fixed even in the liquid state? Let's find this out by an activity. There are three different sizes of glass utensils. There is a juice in this jug. At the moment, we can see that the juice has taken the shape of a jug. Now we will pour this juice in these glass pots one by one. What do you see? Yes, the juice changed its shape every time. This means the shape of the matter is not fixed in the liquid state. Is the volume of juice changing from one vessel to another? No. Therefore, we can say that in a liquid state, the volume of a matter remains fixed. Does the juice flow easily when poured from the jug into the glass utensils? Yes. This means that in a liquid state, the matter is not rigid, but it is fluid. Let us now look at these liquid objects: ink and water solution, sugar and water solution, and aerated drinks. All these matter are in liquid state. The ink and water solution is formed by dissolving one liquid into another. A solution of sugar and water is formed by dispersing a solid into a liquid. And aerated drinks are made by dispersing a gaseous matter into a liquid. By this activity, we can conclude that diffusion of solids, liquids and gases into liquids is possible. You may be thinking, but why? This is possible because the particles of matter move freely in the liquid state, and the particles of the liquid also have more space than the solid. We have seen that the shape of liquids are not fixed, but their volumes are fixed. The attraction between the particles of liquid is less than that of solid because the particles of liquid have more space. That is why compressibility of liquid is possible. In a liquid state, the matter is not rigid, but it is fluid. And diffusion of solid, liquid and gas is possible in liquid. Now finally, we will learn about the gaseous state. You know that all living beings breathe for their existence. Gases present in the atmosphere, especially oxygen and carbon dioxide, are essential for animals and plants. Do these gases have any shape or volume fixed? No. Therefore, we can say that matter in gaseous state have no shape or fixed volume. Now, let's do an activity. Take 3 syringes of 100 ml and close their ends with rubber cork. Remove all the syringe pistons and now let air in the first syringe. Fill water in the second syringe and a piece of chalk in the third. Now try to compress all 3 pistons by putting them in syringes. What did you see? You can see that the first piston was the most easily suppressed. From this activity, we can conclude that gases have a much higher compressibility than solids and liquids. The large volume of the gas can be compressed into a low volume cylinder due to its high compressibility and can be easily sent from one place to another. This compressibility is possible because the attraction between particles of matter in the gaseous state is minimal. Friends, how does the aroma of the food being prepared in the kitchen reach us without entering in the kitchen? The smell of food mixes in the air and spreads from the kitchen to reach us. This is possible because of high speed of particles and large space between them. Gases show the property of diffusing very fast into other gases. So friends, as we have seen that the shape and volume of gaseous matter are not fixed, The attraction between particles of gaseous matter is less than that of solid and liquid, as particles of gaseous matter have more space. Therefore, the compressibility of gaseous matter is much higher than that of solids and liquids. Even in the gaseous state, the substance is not a rigid, but a fluid. And diffusion of gases into other gases is very intense. We hope that you have got a good understanding of the states of matter now. In the next video, we will learn about the effect of temperature and pressure changes on